Welcome back. So now in example 7, we are going to use something called logarithmic differentiation. What this means is that we're going to be taking the derivative of a function where there is a variable in the base as well as a variable in the exponent. So up to now, all our variables have been in the exponents or ln of x. But this is a problem because our formulas won't work because we have a variable in the base and in the exponent. So I'm going to show you guys how you actually approach this problem. So our function is y equals x to the x power. So we need something so we don't have a variable in the base and a variable in the exponent. Well, luckily with exponential functions, we have some cool tricks that we can do with natural logarithms. So we're actually going to take the natural log of both sides. This is going to be equal to ln of x to the x power. So with logarithms, you can take the exponent and move it to the front. So you get ln of y is equal to x ln of x. Well, this is very helpful because now we don't have any variables in the exponents. So we're actually going to take the derivative of both sides, and this is where the implicit differentiation comes into play. So we're going to take d dx of both sides, d dx of both sides, and so now, here we go. So the derivative of ln of y. Well, first of all, let's think what is the derivative of ln of x. So we'll do that on the side over here. d dx of ln of x, as we know, is 1 over x. So d dx of ln of y is going to be 1 divided by y times the derivative of y, which is dy dx or y prime. Now, on the right side of the equation, we need to use the product rule because these two functions are being multiplied. So, if we go ahead and use the product rule, the derivative of the first is just 1, so we're left with ln of x plus the first term, x, times the derivative of ln of x, which is 1 over x. So again, this was broken up using the product rule. So let's just do a little simplifying. I have 1 over y times dy dx is equal to ln of x plus 1. All right. So now we need to get dy dx all by itself. So we multiply both sides times y, and we get dy dx is equal to y times ln of x plus 1. Now we only want our function in terms of x, so we need to go back and think, what did y equal? Well, y was equal to x to the power of x. Okay, so I'm going to write that on the side as well. Y is equal to x to the power of x. That was from the original part of the problem. So then dy dx is just equal to x to the x power times ln of x plus 1. And there you go. That's the derivative. Okay, so the hardest part is taking the derivative of that ln on the left side and knowing when to use ln. Okay, so I want you to try this one on your own. It's considerably more difficult, but I think you guys can do it. So go ahead, give this one a try, pause the video, and then when you're done, unpause. Okay, good job. You've taken the derivative. Now let me do it and see if we got it right. So we have y is equal to cosine of x to the power of x. So the first step is to take ln of both sides. And again, the reason we're taking ln of both sides is to bring that exponent down to the front. Typically, if you want to negate an exponential function, you'll take the ln of both sides. So ln of y is equal to x ln of cosine of x. Now what we need to do is take the derivative to get dy dx. So we're going to take d dx to both sides. And so the derivative of ln of y is simply 1 over y times y prime. Right? The derivative of ln of something is 1 over the something times the derivative of the something. I'll say it again. The derivative of ln of y is 1 over the something times the derivative of that same something. Again, that's the chain rule in effect. Here we need to use the product rule. So the derivative of the first is 1, so we get ln cosine of x plus x times something. So the derivative of ln of cosine of x is, here is the something. This is the inside piece. So it's 1 over the inside piece times the derivative of that said inside piece. So the derivative of cosine of x. Okay? Make sure I didn't forget any parentheses. No, I'm good. So 1 over y times y prime is ln of cosine of x plus x times 1 over cosine of x times, and the derivative of cosine of x is simply just negative sine of x. There's a bracket. So now we're going to do a little simplifying, a little bit more. 1 over y times y prime is ln of cosine of x. Again, it's not ln times cosine of x. It's ln of cosine of x. Then the negative and a negative is, or negative and positive is going to make a negative. And we get x times sine of x over cosine x. So what we do, we're going to have 1 over y times y prime is equal to ln cosine x minus x tangent of x, because sine over cosine is tangent. Now we need to multiply both sides by y in order to get these to cancel off. So you get y prime is equal to y ln cosine of x minus x tangent of x. And then we need to substitute back in, and remember that y was equal to cosine of x to the x power. So then our final answer is y prime is equal to cosine of x to the x times ln of cosine of x minus x tangent of x. And that is the final answer for the derivative. That's it. Piece of cake.